Hi, welcome back. Is everyone here? Yep. Can everyone hear me?
Yes.
Good. Okay, so after listening to all the experts in the first half of the Education Summit, let's listen to some students sharing now. We're happy to invite 5 students to share their Python coding journey. Our first speaker is Thomas. Thomas is a grade 11 student in Canadian International School who has a strong background in math and coding. Based on his own experience, Thomas would like to share with us how he thinks school should be teaching coding. Thomas, you can share your slide. Thank you.
Is my microphone working?
Yeah.
All right. Thank you, Ms. Fung, for the introduction. So, as Ms. Fung has said, my name is Thomas. I'm currently in grade 11 at the Canadian International School of Hong Kong, and this is me. So, here's just a background of my general coding experience and my journey throughout my former years leading to today. So, when I was starting from like grade 3, grade 4, I started using Scratch and block coding as well as MIT App Inventor to generally learn some basic logic and computational thinking before moving on to learning Swift in grade 7, which is a language made by Apple for mainly interfacing with their products and also as a general purpose language. And throughout the years, I've also self-taught JavaScript and Python as additional language just to use in my everyday life. So I'm currently in grade 11 learning Java as my language of choice in the diploma program and utilizing Python in a course with the City University of Hong Kong that would be covering fundamental coding in Python, artificial intelligence, data analysis and predictions, as well as Internet of Things and networking with Python. So first of all, you may be asking yourself, why learn to code in the first place? Generally speaking, technology is all around us and is within everything that we do today, including this talk that I'm giving today. And it is very important to understand the core of how everything works around us. And it's fun to say at least to build and also break some things that may or may not be cool to you. But furthermore, it's important to learn to code because it helps you develop your own soft skills and your hard skills, especially when it comes to problem solving and developing competency with using technology. Because a lot of times when you code, it comes hand in hand with learning how to utilize technology at a higher level than people may typically be using it. And it will also teach you to persevere through problems that you may have seen or maybe some unexpected problems. And these skills can be applied to other areas in your life as well as general education. And now this is just my perspective on teaching programming. By no means am I an educator myself, but it's simply just observations I've made as I've been learning programming, both from my own self-teaching as well as through a specified school curriculum. Generally, code is not for everybody, and that's completely fine. You can't exactly force something onto students who don't want to learn it. And as a result, people will learn code at different paces. So if in the event that you're teaching with a specific curriculum, make sure to accommodate for those different paces. And to me, the most important thing when you're teaching programming and code is not to teach with the languages, but rather you should place a stronger emphasis on logic, because at the core of everything would be logic, and you should work your way up from that. So you should have a strong foundation in knowledge and logic first before you should move on to syntax and general coding things, which may only apply to a specific language. Furthermore, you should also teach students how to work their way through problems, not to copy paste solutions from the internet or from a prescribed teaching material that you're giving them, because a lot of times it is just mindless copy pasting. And I find that students would be very hard pressed to learn from that, as they would not be getting as much interaction with the code per se if they were simply copy pasting instead of manually working their way through it. And it's important to always check back with the students to make sure that they understand what you're teaching them. And one thing that's very important is to teach students from the very beginning to not be discouraged in the face of failure, because it is something that everybody would endure all throughout their programming career. And it's important to instill a school of thought in them that failure would be success in a lot of scenarios, because the best way you can learn is from failing in programming. And content-wise, a lot of times students would not engage particularly well with the curriculum if they're not directly invested in the curriculum. So generally speaking, you should try to aim, if you're building a curriculum, to give students something that they can find relevance in and something that they would see can apply in everyday life. And for education purposes, I would typically suggest teachers not to repeat content year and year. So if you taught a grade 7 class something and they move on to grade 8, try not to teach them the same things and move on to other topics of teaching, because it can sometimes be very mundane for students to be learning the same thing 2 or 3 years in a row. And as a result, a lot of students would not be as engaged in general. And you would have noticed in my previous slides that I may have placed an emphasis on 2 core ideals. The first of this is logic over syntax. To me, there's no point in teaching a language if logic is not taught, because in a sense, if you can understand the full syntax of a language, such as Python, Java, or C, but there's very little point in teaching it if the students do not have the proper logic to apply what they've learned through the syntax. And like I previously said, logic is at the core of everything. So ideally, you should be teaching with block coding first, which is something that's very intuitive for students to pick up and build on top of that, so that students would gain a larger understanding and appreciation of logic that's used throughout programming, and would be able to implement their thinking into their code. Second of all, failure is success. A lot of times students would get discouraged by failures that they might encourage in coding. And it's important to emphasize that it's perfectly okay to fail, and that a lot of times the best way to learn is actually to fail. I myself have experienced this before, and I believe a lot of my peers have also experienced this before. I believe the largest teaching moments would come from times when you don't know what's occurring in your program and you work together to resolve that instead of just being put down by your failure. Here's a quote by Steve Jobs. Sometimes life's going to hit you in the head with a brick. Don't lose faith. This is a mantra that you should teach your students, to not lose faith in your programming. And I think this quote would resonate strongly with every programmer out there. And now general education with Python, seeing as how this is PyCon after all, and there is a little bit of service to Python as a language. And just as a disclaimer, I did not start coding with Python, so my perspective may differ from other students. Firstly, we're going to explore why not to code in Python, which might seem counterintuitive, but in the grand scheme of things, it's important to see why you should or should not use a certain technology instead of just diving head first. First of all, Python is a language some students may see very little applicability, especially at the surface level, because a lot of people might code a hello world, and they might be asking themselves, what can I possibly do with this 1 or 2 lines of code? So at the beginning, it's very hard for students to find meaning in the language as a whole. Second of all, white spacing in Python, which is when you use tabs or spaces to define how code is scoped, can be very, well, cumbersome to say the least for beginners. And both professionals and novices experience it every day when they code in Python. And for complete beginners, general syntax such as if loops, for loops, and while loops can be very unintuitive, which is why you maybe shouldn't start with Python. But then again, you have to ask yourself, why would we use Python? compared to other languages, Python in itself is actually really natural when it comes to read. And there's very little technicality in terms of the way that the language is written. And there's a lot more abstraction compared to other languages like Java or C, which makes it very good for any beginner who doesn't want to get into the nitty-gritty bits of a language to learn. And there's generally little setup in terms of what software you need. And it's a highly supported language, and there's plenty of resources online to search and use. And currently at CNIS, we do block coding from as young as grade 3 using Scratch. And then in grade 6, we're now teaching students to program in Python. And as you can see here, everything's sort of building on top of each other. So you can learn logic first before you dive into a language, and then you learn 2 additional languages on top of that, so that at the core foundation, there's a logical education first. Python as an educational tool can be intuitive for complete beginners in certain ways or another. And to me, it's a very powerful language as a tool, because students can really quickly develop prototype applications as Python is interpreted and not compiled. So they can make a mistake, but they can quickly readapt from that instead of having to wait for the program to recompile. And once you get past the beginner level of things, there's an extensive library collection of libraries and tools that let you do more advanced work with Python, which can be very interesting for students. And in general, Python's used a lot in the industry, so it's a very useful skill for students to learn. And just as like a core thing for making a coding curriculum, make resources for everyone, because they are all learning as either complete beginners or not programmed before. So you should ideally create resources to fit with everybody and make some extension texts for some of the more advanced programmers. And something important to note is that change is practically inevitable, especially with technology. So don't be afraid to switch things up in your curriculum from time to time. However, one thing that's important to note is to not directly throw students into the deep end with very complex tools, software, and languages. And instead, you should build them from the ground up, because if you put them directly into some very complex IDEs like Xcode, then they may or may not start to struggle and end up losing interest overall, because they're simply too confused with the curriculum. And like I've said before, logic over syntax. So this is something that I always find myself going back to, and I believe is at the core of computational education. And lastly, some current projects that I'm making with Python. First of all, as I previously mentioned, I am currently doing a course at CityU, which implements artificial intelligence IoT with Python. So we're currently in the middle stages of learning how to interact with hardware. Next, I'm also doing some web design and networking with Python, and currently creating some small microservices as personal projects to do outside of school. And I've also previously used Python as a tool for data generation and visualization in my math classes. So here's just an example of some of the things that I've made with Python. This was a program to simply help me visualize prime numbers on a grid, which, as you can tell, would be something that might not be used every day, but it shows how versatile Python can be, both in learning as a computational education in general, and also in other fields of education, and which is why I think it's a really useful tool to teach students as a whole. And that's pretty much it. If there are any questions, you can find me at my email, and the slides also linked here. Thank you.
Thank you, Thomas. I can see you probably learned from a hard way, right? Like you have like a lot of warning, like, or suggestions for teachers how they should teach coding in school. Okay, but then like I know that like you have actually like quite good achievement as well. So thank you for sharing. Is there any question for Thomas? You can unmute your mic or you can type in the chat box. Okay, that's fine, no question. So our next speaker is Alex. Alex is a grade 12 student in the same school. 1 year older Alex may not get as many opportunity to code in the lower school, but he has started Python journey through an online resources at his own pace. And he would like to share with us some of the resources throughout his journey in learning Python on his own. So Alex, your turn.
Hi, can everyone hear me? Yep, so my name's Alex. I'm a grade 12 student at Canadian International School. And I wanted to make this presentation about my experience learning Python and the key takeaways that I found and how you can improve your own your own learning of Python. So like Thomas, I started with MIT App Inventor, but where our school usually starts now in grade 3 with this block coding, I started in grade 5 or 6. And after doing this, making these very simple games and small, even animations, I moved on to Objective-C and Xcode, where I learned essentially the basics of the basic syntax and the basic structure of actual code. From there, in the next year, we moved on to Swift to make applications for the iPhone. We did that from maybe grade 9 to, or maybe grade 7 to 10, we used Swift and we were learning Swift. To make applications last year, in grade 10, I made an application for like a lost and found app. It wasn't anything professional, but it was a really interesting learning experience with Swift. More recently, I've focused on Python and C++. Notably, both of these languages are compatible with hardware, and that's sort of my focus for university as well. I want to go a little bit more into hardware. And so with C++, we have Arduinos, and for Python, we have the Raspberry Pi. After that, after learning the basics of Python, I moved on to AI in Python. And so in this photo on the bottom left, we can see all of these different libraries that we used for a project recently, last week actually, to understand a little bit about neural networks and how they work. So the way that I learned Python, they didn't teach Python at school when I was in the younger grades. So I learned Python on my own through YouTube. Most notably, I learned Python, or a lot of it, through this one video from freecodecamp.org, which is a 4-hour video covering pretty much all the basics of Python. And that's pretty much where most of my basic knowledge came from. And from there, I wanted to explore more and essentially use other online resources and other YouTube videos to experiment with the Raspberry Pi, for which I'll talk about some of the projects I did with that a little bit later. Additionally, I used some free online courses as well as paid courses to establish my knowledge. After using the YouTube tutorials, I went to Codecademy, which was a little bit more structured. I had a bad tendency to sort of overexceed what I could do and get very, very confused. So I'd go all the way back to basics. But that's a part of the learning process. I mean, failures are quite natural, and trying to explore is really good because you'll see exactly how it works and you'll figure that out yourself. So the projects that I have, the notable projects that I've made, I started with my first Raspberry Pi project was a weather station, actually. And so using this little sensor that can detect humidity and temperature, I set it up in my room, connected all the wires. I learned to use the library that the sensor was compatible with. From there, I set up a little web server, which worked on our Wi-Fi, and it sent the information over there. And I was able to check the temperature and humidity in my room from anywhere within my house. So it wasn't particularly applicable, but it was definitely, I learned a lot through it. Additionally, I made a speech to text. I made a speech to text application using one of the microphones that the Raspberry Pis are compatible with. And using this, I was able to do some very simple stuff like turn on a light and turn off a little LED with a voice command. And I was also able to turn off the Raspberry Pi with a voice command, which was very, very cool. Another big project that I worked on was actually a model continuous glucose monitor, which was very interesting to make. It was made in C++ using Arduino, but it could have just as easily been created in Python and using using a Raspberry Pi, it could have even been made to work with like internet. And that would have been a very cool thing to explore. Currently, I'm working on a project using computer vision and neural networks to create an AI for diagnosing skin cancer from lesions. And I didn't want to include any photos of the lesions because it's a bit graphic, but basically it uses known facts about, for instance, the width, the size, the shape, the texture of these lesions in order to craft a percentage probability that it is benign or that it is cancerous. And this process has been an extremely long process. I started coding in essentially grade 6. And that is probably the first main takeaway that I'd say. If you're going to pursue coding, you have to be ready to essentially be very, very lost for a good amount of time. It's going to be very confusing. You're going to start completely you're not going to understand anything. For essentially the first couple projects, the first couple things. And that's the thing, you have to go to a really, really big effort to actually understand it. As Thomas said previously, you really want to look over at the logic as opposed to the exact syntax. So you really want to understand what the code you're writing is doing. And you want to understand how you can change it, how you can improve it, how you can adapt it to do what you want to do. And again, the difficulty curve for coding, I think, really, really spikes in the beginning. Because although the hello world may be quite easy, once you start to go past that into, for instance, arrays and functions, if loops, if for loops, while loops, it gets very, very confusing. And this is also true when you pick up a new library or a new concept. So for instance, learning about AI has been very, very challenging because I really don't understand so much of it. And that's just something that you have to work on, and you have to be committed to essentially understanding and really combing through the code. And so my advice to anyone learning would be to start small. So start with Hello World and then make sure that you understand each part of it. And then on Hello World, iterate. So don't jump to a completely new project, but maybe just change some things, maybe add an integer, and eventually start small enough that you can keep adding these small little items, eventually making your code significantly more complex and developing your understanding throughout. And this all ties back to the idea of what I call sustainable learning. So learning at a rate where you don't jump too far ahead and you're not stagnating. So for some education systems tend to use a very, very similar code curriculum for each year repetitively. And that sort of stagnation is not really great for anyone coding, because those who really want to pursue it and really want to go farther are hindered by the courses. Likewise, jumping too far forward really makes you feel quite small, because it's very difficult to understand what these courses are talking about, these videos are talking about, and these projects that you want to do, but you just don't have the knowledge for, which again goes back to the idea of gradually making your way up. And so for anyone who wants to learn coding, I really do suggest that you sort of take some of this advice. And overall, it's really quite beneficial. So yeah, it's Python. It's a great language.
Okay, thank you, Alex. I'm glad to see that, both Thomas and Alex, did not really communicate between the two of them when they are preparing the slide, but they have actually something coincidence, like logic over syntax, right? This is actually very important. And both of you agree that the beginning is actually difficult. And what you missed is the first section of the Edu Summit. Adam, at the beginning of in the first half of the conference, he talked about hardware actually can help students to learn about the syntax. So I can see Alex, you're using all those Arduino, Raspberry Pi to help you get interest into coding. Okay, so the theory actually works. Okay, so thank you, Alex. Is there any question for Alex? Again, you can either unmute yourself or you can type in the chat box. Okay. All right, if there's no other question, you can always come back and ask later. Our third speaker is Declan Young. Declan is also graduating like Alex from high school and go to university next year. He is passionate about coding and really enjoys the satisfaction from different projects. He did a lot of amazing projects on his own with Python, including AI and machine learning in Python. He just recently finished a personal project. I hope he would talk about it. So let's take a look at the different projects he created. Declan, please.
Hello, can everyone hear me? Okay. Yeah, thank you, Ms. Fung, for the introduction. So, as Ms. Fung said, hello, my name is Declan. I am currently a grade 12 student in CDNAS, and today I'll be talking about my experience with Python and also touching upon the idea of applying Python to different scenarios. So, just to give some prior knowledge about some of my experiences before I delved into Python. So I had some experience with Swift, as Alex mentioned, which you can see on the right side, which is an application I made in grade 9 with a classmate, which is a math game. So I've also had some experience with C# for examples such as in Unity and game design, and C++ for my personal project, which I used in Arduino as well. So for my personal project, it's a mini electric piano, which I made through the use of 3D printing, circuitry, woodwork, and coding. So actually underneath it is a circuit board with buttons in it. So then when you click it, it's connected to the Arduino. So it then runs Python. It runs a C++ script, which then plays the corresponding key sound. So now just to give some information on my initial experiences with Python. So I started learning Python around early 2020 during the start of the pandemic, as I wanted to further my skills in coding in general, and also wanted to make productive use of my time. So I was interested in Python due to its simplicity, and perceived simplicity, and the many various applications it has. So as Alex and Thomas both mentioned, the syntax is very different from a standard coding language such as like Java or C++ and stuff, where they use a bunch of white spaces and tabs and stuff in order to show the code. So it's a lot easier to read and it's a lot easier to follow for beginners. So as you can tell, I'm mostly self-taught for Python. So I was actually really fortunate to get a free Codecademy premium subscription during 2020, so I made use of that and did the Python 3 course and the machine learning course. So, and afterwards, I also tried to learn more and further my skills more through resources such as Learn Python 3 the Hard Way, which is a book and website you can find online, and YouTube videos and other types of resources. So just continue on about this learning journey. So like the main way I managed to improve my coding skills, it would be by doing a daily coding problem, or such as some resources I used for that would be like HackerRank and the daily coding problem, which is an email subscription, which sends you a daily coding problem, which you can attempt. And also, while you're on the learning journey as well, I find it best to also read up on things you don't understand. So if you really want to understand how something works and understand the logic behind it, you should just continue to read and ask a lot of questions as well. Asking people who know more about the subject in general is very useful, especially for the subject of computer science and coding. So now just to talk more about machine learning and AI. So I became interested in machine learning and AI because I was predominantly interested in the fact that it's a very big trend currently and also before as well. So I was actually, and also the various applications it has as well, which I will touch a bit more on in the following slide. So I was actually introduced to the idea of machine learning and AI when I was fortunate enough to visit Google headquarters in Hong Kong quite a couple of years ago. So there they gave a presentation on machine learning. However, as I was rather young back then, I didn't understand too much about what they were saying. However, looking back to it now, after I was reintroduced to the idea of machine learning from various online threads, YouTube and others, it really reinforced my will to learn more about how it worked and how to actually use it. So from this, I watched a couple of YouTube videos. I did the machine learning course from Codecademy, and I also read this book called AI Machine Learning for Coders by Lawrence Baroni. So for the Codecademy machine learning course, I would say it's rather unusual in the sense that they don't teach you too much about how it works. I mean, they get you to code some algorithms, but it's really pretty hard for a beginner to understand it. And for this book on the right, I find it really useful if you want to understand how to use TensorFlow, and because it just goes through how to use TensorFlow, some of its applications, machine learning applications as well. And it doesn't go into the nitty-gritty underlying maths of machine learning. So some of the applications of machine learning in general and they're very vast. So they can range from classifying images of dogs as like dogs or not dogs, the cancer cell recognition, as Alex has mentioned, the Google Assistant, and other types of assistants such as Siri, and like object detection and self-driving cars, as you can see. So just to give an example of like one of the aspects of machine learning that I was very interested about and about how it worked as well was neural networks. So I specifically did my IB extended essay on the idea of neural networks. So for my extended essay, I made a Mahjong tile recognizer. And for this, I did this so that I could learn more about, have an excuse to learn more about how machine learning works, how neural networks works, and just to try to do something that I could probably use in the future and get like good experience. So I feel like learning, just learning how all of these things works is honestly, understanding the underlying logic, although it's not necessary if you want to do coding, I feel that it's a really nice thing to do just so that you understand a lot of things. So for this neural network, just to give a brief overview about how it may work. So on the left, you can think of it like in the case of image recognition. It's like all the pixels in the images, you send it through, algorithms are run in the middle, algorithms and processes, and then its outputs like a classification. So now just talk more about some of the projects I've made in PyCon. So considering that I've only really been learning PyCon for about a year now, I haven't done, my Python project is not very extensive. So, but some things I have made are, for example, like a Zoom link shortcut, which is like which was that you could type the last name of the teacher and then it'll open their corresponding Zoom link. So I did this because I was rather tedious during the time when we were stuck at home doing online school. So another project I did was Owl Not an Owl, which is basically an image classification problem which classified something as an owl or not an owl. So for this, I just followed an online website, which made me use an image scraper and then to make the data sets. And then I use the model that they had online to also create the final product. So although I would say I didn't understand too much about the underlying code, it did give me a lot of insight into how the world of machine learning is as well, and how and some of its faults, such as like the problem of having not enough data. Another one is my extended essay, which is I made, as I briefly mentioned, a Mahjong tile recognizer. So for this, I made a convolutional neural network, which is you can think of as an extension of a neural network on Google Colab. So you could upload an image of a Mahjong tile, and then it would tell you like which of the 42 it could be. So for example, like a three circles, or like this Chinese character. So, and also for this extended essay, I also analyzed the effect of activation functions on the training time and accuracy. So by like specifically choosing to do this, it gave me a lot more insight into how the effects of like neural networks, and also allowed me to research a lot more into how it works as well. So just some tips and resources just to help conclude. So my biggest tip would be to just keep at it, because for coding, it's a very, in my opinion, it's a very self-taught skill that you have to want to actively learn how to do and to keep up with, because the idea of coding itself is ever changing, as Thomas has mentioned. So there's a lot of things, a lot of trends that you may have to keep up with, a lot of things you can understand to just try to improve the final product as well. So just keep at it and show an interest. And as Alex said, it's open. So you work slowly. So you could start with something basic such as block coding and then just work your way up. But always start with the fundamentals and make sure you have a good grasp of the fundamentals to then improve on it even more. And it's okay not to understand. So just whenever you don't understand something, it's always good to just research more about it or ask a lot of questions to make sure make sure you understand it, and so that you can probably apply those to future problems that you may encounter in the future or other applications, because you never know when this like thing you learn, such as like how using an array may affect your progress in a task in the future. So just to like completely aggregate some of the resources that I would say are rather good, is that Code Academy. I would say, like, although my one was with the premium subscription, some of the free options are rather good as well. So it's really good if you want, like, as Alex said, a structured way to just understand how Python works, or like some other coding languages as well. So another one is Learn Python 3 the hard way. So this one is better if you understand a little bit about how to use your terminal and some other stuff. But other than that, it's a really good way to just further your knowledge and just like understand more about the basics and reinforce it. HackerRank is good if you want like coding problems to do and to find like more things to learn. And there's a lot of forums on it as well about like discussions about code. LeetCode is good for even more coding problems, and Machine Learning for Coders if you want to learn how to use TensorFlow to make your own models. CS Dojo is good if you want some videos on, like, for example, data structures and algorithms. Neural networks and deep learning if you want to really understand the nitty-gritty underlying maths of neural networks and just machine learning in general. Udacity is good if you want to find some online courses, such as the one I'm doing currently is on data structures and algorithms, so that I can like further reinforce my skills and make sure I understand how they work and how to code them. Grokking algorithms is also for data structures and algorithms. And daily coding problem, if you want to do a coding problem daily to just further reinforce your skills. Okay. Yeah. So now some closing remarks. So I'll leave you with this quote: find something you're passionate about and keep tremendously interested in it. So what this quote says is basically just keep at it, make sure you really like what you're doing, because it's going to eat up a lot of your time. So just make sure you like what you're doing. Thank you.
Thank you, Declan. I like how you say like keep at it, because like you mentioned that you didn't really start intensively coding only since 2020, and I have to say, like, your coding teacher actually mentioned that you have such an solid skill that you're even better than the teacher. So you are like really modest by saying that your project is like actually like it's not really great, but then you actually doing an amazing job. Okay, and is there any question for Declan? Yeah, Declan has actually shared a lot of online learning resources if you are passionate with coding. Okay, so we have finished listening 3 senior students sharing their experience. Oh, I see a question in here. Chris is asking, how you see a YouTube video, this is good enough for a newer? Yeah, I guess like all 3 of you, Thomas, Alex, and Declan, like mentioned that you learn coding through watching videos, right? So maybe the 3 of you can actually like share your experience. You can unmute yourself.
Yeah, so the video that I watched actually to learn Python was by Codecamp. It's a 4.5 hour video, so it's a really long video, but basically it's one video that's got pretty much everything you need to know if you're a newcomer. That's my recommendation. I can drop the link in the chat. Declan and Thomas, any other recommendations?
Yeah, that would be great. Thank you. Is Codecamp free?
Yeah, it's free. It's a YouTube video. So actually, it's
okay.
Totally.
What about Declan and Thomas? Like, what are the videos that you watch?
So I agree with Alex, because I actually use like part of the videos as well. So like free Codecamp is really good if you just need like, because their videos are really long. So like you have to really want to go through it, but they go through it in a pretty easy to understand manner. But like if you want to understand like some concepts and stuff, you can probably find some bite-sized videos from examples such as HackerRank, or just some, for example, like ones like binary search in 3 minutes or so. Like those bite-sized ones are really nice if you just want to understand some like algorithms as well. I understand that you're asking for like newer ones, but like you'll probably come across these data structures as you like get further into your journey as well.
Can you, it's actually on your slide already, Declan. What about Thomas?
Generally speaking, I don't have specific tutorials to recommend because I haven't really done like video tutorials as much, but generally speaking, if you can find like big massive let's learn an entire language in 4 hours videos like Alex would do, but there are also some very nice resources out there that can teach you to do specific things like with specific technology, like maybe for example making an application in Django. You can definitely search for specific technologies out there, and you can, if you want to determine whether it's good for like general learning, a quick scroll through the comments can actually tell you a lot about whether a video is worthwhile for watching or not, because a lot of times these videos are like 20 minutes long and you don't want to invest that much time into it only for it to not be of benefit to you.
And I think sometimes like doing is better than watching, right? Because the reason I say that is Declan mentioned about like daily coding problem, like they give you a coding problem every day. So coding basically is like language. The more you practice, the better you get at it. So if you get a coding problem every day to solve, and then if you like stick with it and really solving a problem every day, I'm sure your skill like will actually just like escalate in a short time. All right, is there any other question? Those are good questions. Okay, if not, we have two more presenters and they are relatively younger. They are like in grade 6 or grade 7, I think. One of them is from a local school, senior secondary school, first year, and then the other one is our next speaker, Moses. He is a grade 7 student from CIS. Let's hear what he wants to share about his Python journey. Okay, Moses, your turn.
Hi, my name is Moses Lee Honching. I'm 12 years old and I go to International Christian School, which is ICS, by the way. I like reading, sewing, and coding. Today, I would like to share with you my main topic about when would be the best time to learn Python. Now, I would like to share my topic experience, my experience with coding. So I spent 6 years programming, and my first ever website or platform, you would say, was Scratch. I was 6 and I spent like 2 years on it, and I really enjoyed it because Scratch gave me the basics of coding and how I could manipulate it and do anything with it. Basically blocks, or because Scratch is just blocks and everything of it. Now, then I moved on to some summer camps. When I was 8 to 9 years old, I was learning how to make things on Roblox, like these games. I personally found Roblox to be challenging in a way, but I still found it fun and creative. And then when I went to Minecraft modding, I would say was really fun. I was able to express myself and give my creativity. Now, for my third one would be VR making. VR making is pretty challenging also, but I would say it's fun, and it would be easy to learn because for Roblox you have to use blocks and create everything from that. Now, when I was 9 to 10 years old, I was learning on a platform called CodePen. CodePen is a platform where you can create websites and everything like that. On CodePen, there was HTML, CSS, and JavaScript. I thought it was really fun, and even though I was confused, later on I would understand it. I learned that HTML is like bones in a skeleton. CSS, the skin, the hair color, the eyes, or and the ears or nose, and JavaScript being like the clothes, the accessories, and all that. And then I would like to move on to a different website, a different platform called Sublime Text. On Sublime Text, I learned a language called jQuery. jQuery was a language, was a different language. It's like Python, but much more different. jQuery was fun, but a lot of things may be confusing on the platform at first, but I believe it was a fun platform to use. Now 11 to 12 years old. Now I'm still currently learning Python after all. I'm on a platform called IDLE. I personally find IDLE to be like Sublime Text with the files and everything, but I thought it was not as complicating. Now, I want to move on to my second subtopic about what are the benefits of coding Python in a young age. So the young age I'm going to be talking about is 7 to 12 years old. So the first benefit for a kid to learn Python in a young for learning Python would be problem solving. Now, in coding, you may run into bugs or anything of that. You might run into something that you don't understand or something that just like a syntax error or anything of it. Now, if you're able to try to define it slowly, people will be able to define the code, able to define what's wrong and trying to fix it. The second benefit of learning Python at a young age would be because it's easy to understand. I think Python is like just like the English language. Now, English is a main language for everybody to understand. Everybody understands, everybody knows, like a lot of people in the world knows English, but some people don't, and I feel like that's just okay. I don't really know what to say. So basically, the reason why I think it's really easy to understand it because it's English. It's basically English, and the print command, as you all may know, the print command is just a command that's just printing like a word on your code on whatever you're making, like print Python. Then it will just print the word Python on it or something. Okay, the third benefit of learning Python at a young age is that about creativity. Learning Python at a young age can help you be more creative because you have this whole entire language and this whole entire platform that you can just do anything on. Now, now with creativity, you can just do a lot of things, just like just try to make a whole entire new game or whole entire new website, whatever you want. The only bottleneck for this benefit is that just being taught. You can go to different places to be taught, in a place I go to like a course, an academy, or you can say academy for coding to learn anything is called First Code Academy. That's a place where I learn. You can also use YouTube videos or anything of it. Now, here's a quick summary if you didn't really catch it. It's problem solving, easy to understand, and creativity. Now, let me move on to my third subtopic. Why choose Python? Well, the first reason why I would choose Python because it's straightforward and easy to understand. The commands are easy. It's like telling a computer to do something. Just telling it to do something, and they will follow it because what else are they going to do? Not follow it? I mean, if bugs, then sure. The second reason why I would choose Python is because there's a lot of like platforms that are free and you can use them. Some platforms that are free are like IDLE, Sublime Text, or Eclipse. Python is a simple and just really straightforward type of language that many kids that learn English can understand. I know I already said this in my second slide, but that's what I think that it is. So let me just share my point of view is that Python is basically English, easy to understand. Now on to my fourth subtopic. My fourth subtopic would be, what would it be like if schools taught Python? Now, since there's a lot of kids in my school, like in around a regular school, I believe there's like 100,000, maybe. I'm not very sure. Since each class would have each class would have kids, there will be more ideas or maybe more estimates or anything of it. I'm not as sure how people think about it, but I believe if a class could work together, they would have more ideas and maybe just have more things to share, and everybody could just grow together and learn. Now, I also think that Python is a healthy, and people can gain more knowledge and experience from it because hello, computer science, you're learning a little bit more about computers and everything else. To sum it up, I believe that Python is the best time to learn Python. I would say to learn Python is to be in young age. And the reason being is because people will have a growing and learning mindset, and people with a young age would be full of energy. Another quick summary: benefits, ideas, knowledge, and skills. And financial support, I will go on right now. Financial support being that some kids will not be able to learn. That's why, like, learn from other academies or any other things. So YouTube videos or school could also help that. Thank you.
Thank you, Moses. I think like throughout all the students share, the word confused, okay, like seems to come in at all four presenters so far. But thankfully, like everyone actually did say, as long as you keep at it. Okay, as long as you stay on, later on you will understand. I think Python is like, because the syntax is simple, it's like English, it's just a language, right? So the more you keep at it, the more you work on it. Don't give up, then you will be successful. Okay, does all four of you agree? Okay, is there any question for Moses? Okay, let's move on to our last student presenter, Gordan. Gordan Tam is a year one student in the King's College, Hong Kong. He enjoys coding and went out for lessons to learn about coding. Let's see how he uses his different resources as his learning platform and created a game with PyGame. Thank you, Gordan.
Hello, everyone, and hello, everyone, and today I'm here to share my experience in learning Python. So here are my experiences in coding in general. I started learning coding around 2 years ago with Arduino and made my first project, an automatic fan, at around the same time. The automatic fan is pretty simple in my opinion. It merely just shows the temperature and will control the fan's power and also show a few lights depending on how high the temperature is. It can also show the humidity, so it also acts like a shower for like the nearby temperature and humidity. It's also kind of small, so I feel like it was kind of cool. I mainly got into coding because I felt like it is cool to make fun projects that can help some people, and seeing your own effort pay off after spending a lot of time on a single project. So how did I get into Python, which is actually the main part of the talk, as this is PyCon after all. I started learning Python around a year ago, mainly because I was starting to get kind of bored of the hardware. So I tried something more related to software, which in my case was Python, because I feel like Python was easier to understand than other types of code, because it's more simple and and the dots, and it's not as complicated as some other coding languages where you have to type out long amounts of code and use different blank spaces and etc. So Pygame. In my last slide, I mentioned that I like making stuff with Python, and that is technically speaking kind of a lie, because I usually make games with Pygame most of the time, and my biggest project so far, Defend the Fort, is made with Pygame, and I spend around an hour a week with it, but I still enjoy coding with Python because you can make some lists and also a lot of things that can help you analyze a bunch of data, instead of Pygame, which is more like a one that you make something that you play around with, instead of something that is more useful to your daily life. Challenges. Of course, anything that anybody tries to make is bound to have some problems or errors. And the biggest one I had was trying to implement the buy system for the weapons in my Pygame. Thankfully, with the help of my coding teacher and a good amount of researching, I pulled through. Giving up. I'm sure a lot of people have this feeling when dealing with a hobby that takes up a lot of time. It affects your academic performance, shortens your playtime, and more. But I think that if you truly enjoy doing a hobby, you will strive to never give up, which is why I've never stopped this hobby of mine, and hopefully I never will. Timeline of events. I'm sure you guys might be slightly bored of these long texts, so here's a timeline of my coding adventure so far. I've actually used different languages, but I decided to cut it out because it's not as important, such as MIT App Inventor. So 2 years ago, I started coding with Arduino. 1 year ago, I started with Python. And 3 months ago, I started with the Pygame project that is still ongoing. Hope everything else that comes next is cool and will help me coding in the future. Learning. Coding is fun, but can be deeply confusing with the syntaxes, different languages, so there's a lot of things you need to keep track of. I think one of the most important things is to try some foundations before going up and making some complex applications. All of this builds together to the most important part, in my opinion, and that is you need to understand your own code and know about the logic board instead of how the language is typed and the different functions inside a language. Because with the language, you can just search on the library and then learn about it more later. But if you can't really understand the logic of how your app actually works, you're basically just blindly copying some code. So I feel like if you're just copying some code, that's not really making an app. Even if you compile a lot of things together, that's still kind of unoriginal and boring, because you should probably exercise your own skills so you can make yourself be able to do different projects more easily. Finally, I want to give some thanks to some people that helped me code it. I don't really learn myself. Actually, I do look at some YouTube videos and some tutorials, because sometimes when I'm trying to work on a project on my own, I can't really think of how I actually can do it. And there's some things that I'm not sure about. But I usually go to Blue Technology to learn about coding in general. I think the teachers there are really nice and helpful, so I would recommend to any coding newcomers to learn over there. All these amazing projects I've made are partially thanks to them, so I would like to give them a sincere thank you in my introduction of my Python experience. Finally, I think all types of coding are fun, and especially Python, so I hope people here will try out different languages of coding, and that's all I have today. Goodbye, everyone, and have a great rest of your day.
Thank you, Gordan. I think all coders need to have a growth mindset, right? Like you all have to believe that I can do it. I can do it. Like as long as I keep at it, I will be doing it. I will be able to do it well. Okay, and like you all mentioned that YouTube is actually very good learning resources. Just to let you know that we have recorded the sessions and we will upload your presentation to our YouTube channel after the conference. So this will be an added resources for other educators around Hong Kong or even around the world to understand like, how students think about learning coding at a young age. Okay, and then hopefully, well, actually, like I guess like students who are younger actually are more lucky because like now schools are actually teaching coding language at a younger and younger age. So thank you so much for your sharing. Oh, actually, I forgot to ask, is there any questions for Gordan? If not, so thank you very much for everyone to share.
Actually, there's a question in the chat. So
Yeah, a
just
question for all of us. Declan, why don't you go ahead?
okay. So
Read out the question is.
yeah. So yeah, so I feel that like Python should be probably, or at least some sort of formal coding should be taught in school to at least some degree, so that because it's going to be an integral part of the world going forward. So having like some basic knowledge of it is rather useful. However, I do feel that like the school curriculum is usually never enough, so you should probably learn a bit by yourself as well. And also, gender has like no implications. If you are really interested, just go for it. Doesn't matter if you're a girl or boy. Just if you're really interested, just make sure you have the time, passion to do it.
Yeah, I totally agree with Declan. I definitely think it should be Python should be taught more at school. But I also think that to get to like a good level or a really applicable level for the real world, you definitely have to pursue it outside of school as well. But like it's sort of the same thing with any subject. If you want to get really like a lot better at it, you have to have your own interest in it and pursue it beyond the curriculum in your own time.
What Declan and Alex said, really, I do generally agree with. It is something that should generally be taught in terms of the general curriculum, and at the same time, you can't exactly force something onto students that don't like to learn it. So at a basic from an educator standpoint, you have to recognize that, but it doesn't mean that you shouldn't try to teach them. Inherently speaking, they'll still pick up something along the way, whether they'll use it or not in their daily life. Formal teaching in coding in general, to me, I think, is something that's very hard to navigate through because you'll a lot of times have students that would be learning at different paces by themselves. So you would have to accommodate for a variety of different types of learners because some people might learn better from a direct lecture while others might learn more from a do-it-themselves kind of mentality. So you would have to accommodate a lot when you're teaching code in a formal context.
So,
Yeah, sorry, Gordon, go ahead.
So for me, I feel like formal teaching is nice because coding is used a lot in the daily world, but if it's compulsory, then that could be a little sketch because maybe some people don't really like coding at all and they wouldn't be that interested in it. So it may be compulsory, but to like a very basic extent, to like how it's like computer lessons in like primary school where you don't really have that much you have to learn about, and it's a lot of just basic things that they just teach you. So if you're interested, you should still probably go pursue it somewhere else because the school can't really help you that much because in a school curriculum, it's not just teaching one student, but a lot of them at once. So I think it's good, but there should be like very simple and not that complex.
What about Moses? Do you have it your share?
Well, I also believe that if you really want to pursue something, yeah, just use your own time, and I think that Python should a little bit like coding in general should be a little bit more popular around schools because if it's more popular, then people get to know it and people get to study a little bit more about it. So, and I really don't. That's really all I have to say so far. So, yeah.
Okay, thank you. I can share something from the teacher's perspective, and actually borrowing Thomas' idea. Like Thomas mentioned that coding is not for everyone, and that's okay because coding is actually really not like, I believe that coding is really not for anyone, but logic is for everyone. Okay, so I think like the school can actually teach students at young age about logic, like doesn't matter what language they use, but then Python is a good language because it's similar to English. So everyone know English, like Alex says, right? Everyone know English. So Python is a language that a lot of people can understand. And through Python, you can actually teach students logic at a young age. And then even though you're not interested in coding, but then you can learn logic from there. And then if you are actually really passionate or feel interested after the school has exposed this this curriculum to you, then you can use your own time to explore more and invest more, because this becomes your hobby, because this becomes your interest. And it's really natural for you to invest more time to something that you're passionate about, right? All right, is there any other people who want to share their comment or their thought? If not, then thank you for everyone who participated. Either you share or you actually stay and listen to all the presenters presenting. Thank you so much. Like I said earlier, your presentations will be uploaded to YouTube, so you can let your friends or like encourage people who want to learn about Python to take a look at the videos as well. Thank you so much for today, and stay safe in this Typhoon 8 Saturday. Thank you.
Thank you all. Goodbye.
Bye.
Thank you.
Yeah, thank you.